Good morning, students. This is Sheba. Now we are going to see about the microprocessor and microcontrollers subject. Moving into the subject, let us, since it is an intro class, let us have a brief overview of what we are going to learn in this subject. Basically, we all heard about this word microprocessor and microcontrollers. Nothing but the microprocessor is said to be the processor which does specific operations for the specific applications. That is microprocessors. From the name itself you can say it is the brain of computer which is implemented within a single chip. Micro and processor means a device that process the binary numbers 0 and 1s. To process means to manipulate, to do some operations or some applications what we are meant to do. And microcontroller, you can see the major difference between this microprocessor and microcontrollers. If you go to the interview, if you go to any core based companies and all, first thing you have to keep in mind is what is the difference between this microprocessor and microcontrollers. Processor, it just processes the given input and produces the output, whereas microcontroller, the name itself indicates the controller. It has overall control. It has memory, peripheral devices, interfacing devices, everything within it. We no need to go for external peripheral devices or memory. Whereas in the case of microprocessor, it only process, it doesn't have any memory or interfacing devices. So that is the major difference between the microprocessor and microcontroller, and why we are moving to the microcontroller from microprocessor. So in this subject we are going to learn about this microprocessor, a basic microprocessor which was developed earlier, that is 8086 microprocessor and 8051 microcontroller, and other ARM and PIC microcontrollers also we are going to see in the forthcoming units. So these are all the things we are going to learn in this subject. So here I have mentioned the syllabus of all the 5 units what we are going to see. As I have said, the first 2 units will be dealing with 8086 microprocessor and its bus architecture structures, and third unit will be full and full IO interfacing. What are the interfacing controllers we are using, what are the purpose of using those interfacing, and fourth unit fully will be 8051 microcontrollers, and fifth unit will be the application of this microcontrollers, interfacing purposes, as well as ARM and PIC controller will be learned. So these are all the things we are going to learn in this total 5 units. So I have mentioned the book references also which you can use for this microprocessor and microcontroller learning. Textbooks preferred, maximum Muhammad Ali Masidi will be preferred as a textbook, and apart from this you can also go for reference books like Douglas V. Hall reference book, as well as some local authors are also available. So these are all the books I have mentioned, and basically it will be easy for you to learn using the video lecture. So I have given the video lecture links also in this slides. And regarding the application microcontroller and microprocessor, so I have clearly applications of this microcontrollers as well as processors. You can see these microprocessors are major it is used in digital clocks, in gaming devices, video games. Everyone will have come across this video game. So this microprocessor is mainly used in those video gaming and all, and digital clocks. You can see LCD, LED clocks, everything works on the basis of this microprocessor. And microcontrollers also, robotics, embedded systems, everything come under this microcontroller. And regular daily use washing machine comes under this microcontroller embedded systems. So everything automatic operating every devices comes under this microprocessor and microcontroller. So it is nothing but our mobile phones, laptops, daily life, we are using this microprocessor as well as microcontrollers. So learning will be easy if you will be going and learning it in real time. So what is the mobile we are using, what is the processor behind it, and how that processor works, why we are going for that processor. So if you can see, even you can take the generation of the mobile phones. First we are using a 1G 2G mobile phones, after that 3G 4G, now 5G has evolved. So it goes on, the technology goes on. So what is the major difference lying between different configurations of mobile phone? So they are saying this processor is very advanced. What is the advancement? You can learn that. Laptop, palm top, whatever it is, what is the processor used behind it? They are changing Intel core processors, Pentium 4 processor, 5 processor, Duo processor. So everything is go on changing. So you can learn from that. So these are all the real-time applications of our microprocessor and microcontrollers. So you can learn from that in real time. As I have said, this microprocessor is nothing but a processing device that fetches the data, processes and produces the output. So the history lying behind this is, there are many types of processor available, as I have shown in this diagram. Socket type, pinless processor, slot processor, and many slot processor, multi-slot processor are also available. So these are all the development of the Intel microprocessor from 1975 to 2001. And you can see the generation of these microprocessors. 8080, which is a 8-bit processor, next 85, 86, 88, many types of processors has evolved. And you can see the types of processors: Pentium, Pentium Pro, Pentium Xeon. So Titanium 64-bit processor has also evolved. And the first microprocessor which is first ever evolved is Intel 4004. So this is the first processor which was invented in 1971 with a very minimum clock speed of 740 kilohertz. So of course our microprocessor works on the clock speed base. So based on this clock speed, it decides the speed of the processor. And after that 4040 processor is developed, which both these are 4-bit processor. And moving to the 8-bit processors, 8008, this is the first 8-bit processor, and 8080, 8085 is the one of the majorly used 8-bit microprocessor. And after that you can see 16-bit microprocessor, which we are going to see in this subject, our Intel 8086 microprocessor. After that 8088 and 8186, 188, 286, many processors have been evolved, but still 8086 is used in most of the applications. The reason behind is the features available, the compatibility with it, the working speed of this processor, and the cheap rate. So these are all the reason why we are going for this 8086 mainly. Then 32-bit microprocessor, you can see 386, 486, and Pentium processor, Pentium Pro processor, and Pentium generations 3, 4 dual core processors are also evolved. And after moving to the 64-bit microprocessor, Intel Core 2, i3, i5, i7 processors have been also developed. So major there are some basic terms we are using in this microprocessor. You can see bit, as we know, binary digits, zeros and ones, and byte, word. You can see these are all the basic terms that are available in this microprocessor. Data, what we are going to take on as the input, what are all the operations we are going to do. Address, where our data is available and where our data is taken. Clock, as I have mentioned, it represents the operating speed of the microprocessor. It is a square wave which is used to synchronize various devices with our microprocessor. And memory capacity of the available and external memory is available. Next, bus concept. Bus is nothing but in general we know that what is bus. Bus is used for transportation purpose. Similarly, here microprocessor bus, it is used to transport the data from microprocessor to the external peripheral devices or from the other outside devices to our microprocessor. So there are Three buses available in major: data bus, address bus, and control bus. Apart from this, there are CPU bus, control overall central processing unit, as well as the system bus, which is used to operate within the system. And here tri-stage logic is used to operate this input driven circuit. High state, low state, and high impedance state is the three states available in this logic. So this is the basic microprocessor system: input and output processed by the CPU. Secondary devices are used for storage. The history and basic process lying behind the microprocessor. Now we are going to see about the architecture of microprocessor. As we know, this architecture is the basic and the most important question available in this microprocessor. So when we are going to learn any microprocessor, the first thing we have to keep in mind is it's the architecture or layout of the microprocessor. Why it is important? Of course, the architecture decides how the microprocessor is structured, how it is featured, how it will be serving the application we are needed. So based on the application you are taking, for example, as I have mentioned earlier, if you are going to use a digital clock, a simple implementation of the microprocessor, how its architecture has to be defined. And if you are going to use it for some advanced applications like video gaming, so how its architecture have to be redefined, how it can be implemented for that particular application. So based on the application, you have to find the architecture and the features available. So the basic thing first you have to know is the architecture which is basically available in your microprocessor you are choosing. So here in 8086, first we are going to see about the architecture available. The architecture here is separated into two major units. First one is the bus interface unit and the second one is the execution unit. As we have said earlier, basically this 8086 microprocessor is also used to perform the fetching, decoding and execution. So fetching is done in this bus interface unit, whereas in decode and execution is done in the execution unit. So fetching means is it send the address of the data where you have to pick up the memory data, and it goes to that particular address and fetches the data. It return back to the microprocessor. It process in the execution unit and produces the output. So these are all the functions that is carried out in your microprocessor. You can see the blocks available here in this bus interface unit. There are segment registers available. 4 segment registers major available. That is extra segment, code segment, stack segment and data segment. So from the name itself you can identify data segment is used to get the data and store for temporary purpose and produce the output. Stack is nothing but temporary storage. So temporarily you can store and produce the output. Code segment, and code segment here is used to code the data, whether you have to encode the data or code byte. So it is used for that coding purpose and produce the output. Extra segment is also used for storing the data values used in the program. And you can see the pipelining is nothing but as I have said, the major operations like fetching, decoding, executing is done in a parallel fashion. So first before pipelining, the process is done. First fetch phase will be done, after that decode phase will be done, after that execution is done. Whereas in pipelining, instruction 1 is fetched, and if it is moved to the decoding phase, the instruction 2 is fetched. So parallelly all the process will be taken simultaneously, and so we can process multiple instruction at the same time. That is the purpose of using pipelining. And you can see in instruction Q, it is used to queue the data you are giving as input. And also many flank registers are available here. Arithmetic logical unit, which perform the ALU operation, control system for overall control, and instruction decoder to decode the instruction. There are also general purpose registers like AH, AL, BH, BL, CH, CL and DH, DL are available. You can club this like AX, BX, CX and DX to perform the 16-bit operations. So these are all about the architecture in 8086 microprocessor. If you have any doubts in this, you can ask me and get the details. Thank you.